If a sports car can do 250 miles an hour, why not just get 4 engines and do 1,000? This is a question my son asked the other day, and while the math seems to add up, there's one very important thing which means this can't work, and that is drag. Drag is the force that you feel when you try to move something through the air. The odd thing about it is that it gets much stronger the faster you try to move through it, until eventually you don't have the power to go any faster. Think of a skydiver. When he jumps from a plane, he doesn't keep accelerating all the way down. He reaches a point where the drag equals the force of gravity, and he doesn't move through the air any faster. It's exactly the same when you drop a stone in a pond. It briefly accelerates and then floats down at an even speed. This graph shows just how much the drag increases as we accelerate our car to 1,000 miles per hour. You can see how it's quite flat at the start, then quickly climbs, and how it gets even steeper in the transonic region. That's because friction from shock waves causes yet more drag. At double its top speed, our car would experience 4 times the drag and need 8 times the power to achieve it. To cope with the shock waves and reach 1,000 miles per hour, it would need over 90 engines. Luckily, jets and rockets have much more power for their size than petrol engines. To reach 1,000 miles per hour in just 5.5 miles, Bloodhound needs still more power so that it can accelerate quickly. With both the jet and the rocket, it has over 20 tons of thrust. But at 1,000 miles per hour, the drag will be starting to get close to the thrust of the car. On the plus side, drag will play a very important role in helping to stop the car. As the engines are switched off, the air will have a braking force of around 15 tons, and it will certainly feel that in the cockpit. Later on, the air brakes will deploy, increasing the frontal area and helping to slow the car further. And finally, parachutes, if they are used, will do the same thing again.